So, hello everyone to our lesson, Mathematics, Form 2 on probability. Okay, the last topic. Now, before I move into Form 2 Maths, okay, I would like to just recap your knowledge, refresh your knowledge about what is probability. Now, what do you understand by the word probability? It means something that can possibly happen, right? So let me ask you, what is the probability of the sun rising tomorrow? Can I have your answers in the chat? It's like, what's the probability of the sun rising tomorrow? How would you write it? Can I have some answers in the chat so that I can see? My question is just like, what's the probability of the sun? Yeah, possible. Possible? Really? How possible? How much possible? If possible is your answer, that means there could be something impossible as well. Correct. So very possible means what? What is another term for very possible? Very possible. It means very sure. Am I right? So the word here is surely. Do you understand? That means 100% it's going to happen. Now, this may actually bring you back to your basics of probability. Do you remember if on one side is going to be something very sure to happen, what's going to be the other side? That means tomorrow is going to, okay, tomorrow the sun, tomorrow there will be two moons. Or maybe tonight we can see two moons in the sky. Not possible. Or in other words, impossible. Okay. Or we can just go with impossible. All right. So we'll write on the other extreme, impossible. All right. Now, what is the probability of you getting heads when you flip a coin? You know, when you flip a coin, you get head or tail, right? So what's the probability there? Can I have some answers in the chat? Correct. 50-50. You always go with that term, 50-50. What is 50-50 in words? How do you say that in words? 50-50. That means it can happen, it cannot happen. It's like, 50-50. What do you call that? This is a term you learned in statistics. Siddharth, any words that comes to your mind? Equally likely. Does it ring a bell, guys? The word equally likely, that means the probability is half. It can happen. Okay? All right. Now, having said these three things, these three events, something is impossible, some things are equally possible or equally likely, some things are very sure to happen, or another word here would be certain. Okay, certain. All right, surely or certainly. Okay. Now, what about this range? What about things that happen here and the things that happen here? Can somebody tell me? This is your standard 6 literally. Why do I need to do this? Because this basic knowledge carries up after this. What about the events that happened here? What about the events that happened here? Do you remember the words there? For example, I will wake up late tomorrow morning. It's like, I will wake up at 5 a.m. tomorrow morning. But every day you wake up at maybe 9 o'clock. So what's the probability that you will wake up at 5 o'clock? It's less likely. It's not impossible. Okay, it's not impossible, but the chances are less. Do you understand? So the word here is less likely. Do you remember this terms all? You know? Can I have a thumbs up if you do? Anything from impossible to equally likely is less likely. Now tell me what's the other side then. If this range is less likely, what's this side? More likely, exactly. More likely means more likely to happen. So when you see an event happening, guys, you have to put them either into these 5 categories. Either it's impossible, either it's less likely, equally likely, more likely, or surely going to happen. Is this clear for you guys? Do you understand this part? Can I have a thumbs up if you understood this explanation? Because this is more like your basics, okay? Now let's get to connecting probability with some numbers. Now, instead of writing it in words like that, we put in numbers, values. So what is impossible? How do I show impossible as a number? Anybody take a guess quickly? 0. Fantastic. What about surely certain? If something's going to happen for sure, what do I put? No, 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 no. I'm not talking about percentage here, guys. Percentage, yes, 100% can. But I'm just talking about a number. You guys went to 100. Now, 100, I would go if I'm talking about percentage. So this is where you learn that if an event is surely to happen, it is 1. Okay? If an event is surely impossible to happen, it's 0. What about an event that's equally likely? Just now only you told me the answers. What was that? Correct, 0.5. 0.5 as a decimal. This is also same as half. Correct or not? Yes or not? So you can write it as a decimal, you can write it as a fraction. Doesn't matter. But equally likely is 0.5 or half. Okay? Which means if your probability is more than 0.5 until 1, then it's more likely. Any number more than 0 but less than 0.5, it's less likely, including all the fractions. For example, 1 over 4. For example, over here, 3 over 4. Do you see your fractions coming into picture here? Now, the third element of numbers is where you bring in percentages. That's it. 0, every number here times by 100. So 0.5 times 100, this is 50%. 50% chance of something happening. That's why the term 50-50. And here, yes, you can go with 100%. You must say percent. That's what refers to percentage. And here will be 0%. Got it? So you can express it as a fraction. You can express it as a decimal, 0 and 1.0. Or you can choose to express it as a percentage. Remember, fractions, decimals, and percentage are all related with each other. Clear now? Clear? Are you clear? So probability deals with all numbers from 0 up to 1. Do you understand that first? If I say the probability of this event happening is 1.5, am I making sense? If I tell you a number like this, am I making sense? Yes or no? Answer in chat. No. This is the first basic knowledge that I want you to have, to remember. Okay? Shall we move on? Okay? Clear? Right? Faham ke semua? Okay. All right. This is just me explaining. I want to see your answers there. Okay, good. Clear. Now we move on. Okay, this is just the basic takeaway knowledge you need. Okay. So let's have, okay, I'm going to skip this starter activities all, okay? You know coins. When you flip coins, they're always going to be equal. After this, how do they come to this? Is because they repeat that experiment 100 over times. Okay, then they come to an agreement that flipping a coin is a fair event. A fair event means it's 50-50. The chance is equal, 50-50. It can happen. Either you can get a head or a tail, and they are equally likely. You remember that line that I drew just now? Equally likely was in the middle. Does it make sense now? Okay, so my question is, are these events fair or biased here? The event is fair. But unless you put some kind of weightage on one side of the coin and then you flip it, then it always lands on the other side. That's bias. That's cheating already. Okay? Probability is the main idea behind casinos, and that's one of the biggest money-making businesses in the world. Do you know that? Okay? casinos where people go and gamble. It's all about probability, but learning probability is not about gambling. All right, clear that out first. Okay, probability is all about maths. In fact, there was once upon a time, maths professor used probability analysis and tried to actually win the lottery tickets by coming out with a probable number that might be actually coming out in the lottery, whatever. Okay, all right, let's get to questions now. Okay, yeah, yes, everything is about real life. Maths is all about real life. Okay, so I want you to tell me whether these events are fair or biased. Rolling a single normal dice. Do you think this is fair? If you think it's fair, put in chat. I want to see answers from all three of you, four of you, whoever. Is it fair? Siddharth, where's your answer? Rolling a single normal dice. Is it fair or not fair? Quickly. It is fair. Okay, now let me ask you, what is the probability of getting a 1 when you roll a dice? What is the probability of getting a 1? Very good. See, you know this already. It's 1 out of 6. What is the 1? 1 is the possibility of getting 1. 6 is all the possible outcomes. Correct? What is the possibility or probability of getting an even number? How about that? When you roll the die. What about that? The probability of getting an even number. Very good, Gloria. 3 over 6. And how did we get that? Even numbers means you can get 2, you can get 4, you can also get 6. Do you understand? So there are 3 possible answers out of a total of 6 answers. There you go. This is the basics you're going to learn here at this point. Okay? Now, let's go to this spinning wheel. Look at this spinning wheel here. There are 5 different colors here. What is the probability of getting a red or the spinner landing on the red section? 1 over 5. Very good, because there are 5 colors. You've got 1 color, so you choose. Okay, so it's 1 over 5. Now, next question, last one. So it's fair. Okay, and the probability also you have said it. What about this? Is this a fair experiment or not? This third spinner? Yeah, it's not fair. It's biased. Why is it biased? Because the chances of you landing on a yellow is literally more, correct? And this is where we can actually also calculate probability. Probability is not, oh, I will only calculate for fair events. No. Here, it's a biased event. Why? Because there are more yellow, then there are definitely lesser red and blue. They're kind of lesser than green. So yellow stands the highest chance, followed by green and equally by blue and red. Can you see that? And I can calculate the probability for each. You see that? Here, it's equally likely. Here, it's equally likely because it's fair. But in something like that, you'll have then what I told you as that line. You remember? Some things are for sure. Some things are never going to happen. Then the equally likely is in the middle. So some things are going to be more likely. Some things are going to be less likely. Do you understand this picture now? And where are we getting our numbers from? And trust me, they're all going to be less than 1 and more than 0. Okay? That's your basic knowledge. All right. Let's move on. Cukup lah, I think this one. Okay. Now we go to our slides. Okay. Hold on. Let me open it up. All right, here. Siddharth, are you there, Mr. Siddharth? Can you start answering? Okay.
Yes.
Yes. All right. So guys, in your Form 2 syllabus, you have got a few things, but trust me, this is really easy. Okay. This word experimental probability means it's just, you do it in a small scale. Okay. But when you do something in a small scale, let's say you come, okay, I got this probability lah, okay, of me winning this particular thing. Okay, this is the probability, my chance of winning this football game that I play. Every time I play a football game, I win 0.6 times. 60% I win. You know, let's say you say like that. That's an experimental probability. Maybe you played 100 games, you played 1,000 games. Then it becomes a real probability. Do you understand the probability of a real event? So experiment means like literally it's small, but that's not the main important thing here. The main important thing is what is probability? Now look at these keywords here. Ratio. Another important word, frequency, event, okay, number of trials, or how many times you play or you do something, okay? So ratio, the word ratio, you learned this when? Last year, maybe, right? So what is ratio? You understand what is ratio or not? Ratio is like parts, right? How did that come into probability? So just now itself, when you talked about probability, weren't you talking about fractions? Yes or not? Correct? You were talking about half. You're talking about zero. You're talking about any fraction which is more than zero, less than half, more than half, and complete one whole. Yes or not? Ratio is very much related to fractions. You know that, right? So ratio, it's part to part, two parts to three parts, or two parts to a total of five parts. And that's where it becomes a fraction. Frequency, how many times an event is happening. You learn this in primary school. This is called mode. An event that's happening a lot of time. The one with the highest frequency is known as the mode. Am I refreshing all your memory back? Frequency, how many times it's happening? How many times you go to the toilet in a day? Maybe if you did an experiment, okay, how many cups of water you drink? Your family members drink. So maybe your mother, she drinks 5 cups. Dad drinks 8 cups. You happen to drink, your child happen to drink 12 cups. Okay, so who has the mode? The one with the highest frequency, 12 cups. You see that? Of an event. In this case, this event is drinking cups. So when you talk about probability, just like how you did just now, what's the probability of getting a yellow? Okay, what's the probability of getting a 1 in a roll of dice? You see that? It is a ratio. Earlier you told me 1/6. Remember? What is this? This is ratio. 1 part out of a total of 6 parts. 1 is the frequency of it coming out. Then when I asked you even numbers, there were 3 even numbers that you gave me. So the frequency is 3 out of a total of 6. The event is you getting an even number. That was the event. Do you understand? Now, the word or the sentence of probability, what it means? Okay, let's see examples. Examples are way much better. Okay, so let's see our first example. And these are some important words. Sample space. So I'm going to take you back to that easy rolling dice experiment. When you roll a dice, what are the possible outcomes? You could get 1, you could get 2, you could get 3, you could get 4, you could get 5, you could get 6. This would be your possible outcomes in that experiment. Can you get 7? Can you get 8? Can you get 0? You cannot, because that's not in your sample space. Do I make sense now? Does this make sense to you? What is sample space? Don't think this is about astronomy, yeah? No. Okay, this is not about the stars or the constellation. The space that we're talking about is this. What is your data, your possible events or possible outcomes of an experiment? Okay? Event means it's a set of outcomes that satisfy a certain condition. Like just now, what is the probability of getting even numbers? You see that? So that's called an event. So I have a condition right now. I can change this. What's the probability of getting prime numbers when I roll a die? Hey, that's also a possible question. What are prime numbers here? 2, 3, and 5. We have got 3 prime numbers there. Can you see? So it's again 3 out of 6. Do you understand what I'm speaking about now? What's the meaning of sample space? What's the meaning of event? Because these are words that you are going to be tested on. Okay? So let's move on. Examples. Okay, over here now. Look at this question. Choosing a month in a year. Guys, and the event is, event Z, okay, our event is getting a month that has 31 days. So first tell me, what's your sample space? What is the sample space? What are all the possible answers that you can get for the months in a year? And you can start with listing down January, February, March, April, May, June, blah, 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 until December. Yes or not? Correct? So my second question, and that's known as S, a big capital S. You write that, you can write equals, and you put a bracket there, and you can write January, February, March. If ever the question says, state the sample space, this is what you must do. Question asks, what is the number of elements? You know what's number, right? How many? How many things you have inside here? Can I have your answer in the chat at least now? How many numbers? How many months do we have in a year? From this sample, January to December, 12, exactly. So your N is 12. Got it? Your S, your space, your sample space is January to December. The number of elements in that sample space is 12. Now, what about the elements in the event Z? How many months has 31 days? That is a bit more specific. It has a condition. Siddharth, what's the answer? All of you put in your answers. How many months has 31 days? Tell me the number straight away. January, February, no lah. March. So January, February, March, April, May, June, July, August, September, October, November, December. That's right. I got 6. January, March, May, July, August, October, and December. Yes, we have 7 months. That has 31 days, dude. Okay. The rest of another 5 months. No. 4 months has got what? So 7 months has 31 days. Correct? 1 month has got either 28 or 29 days. That's our February. And then another 4 months will have 30 days. Do you know that? Do you even know this? I hope you do, huh? Can use your knuckles, all right? Okay. So the number of elements means how many lah in this event Z is 7. We have 7 months. What are they? You can list down January, okay, March, May, July, August, October, December. Can you see? Do you understand now this question? All right, let's go to the next question now. Choosing a letter from the word environment. So now, what is our sample space? Our sample space is all the alphabets from E. Okay, we have E, some more, N. This is our sample space lah. Some more, V. Can you see? I find one V. That's it. I, R, O, N. N is already there. So I cancel the N. M is not there. And then T. It's not the same spelling again. Why? Because N repeats itself. Can you see or not? This is like the mode here. N is like the mode. You see? So these are our sample space. Okay, how many elements do I have in that sample space? At least you tell me this. How many elements are here? What's the answer? Come on, look at the screen and answer. Very good. 1, 2, 3, 4, 5, 6, 7, 8. Good job, Fatin. So our N is 8. Do you understand that? Okay, Siddharth, pay attention here and answer in the chat, please. Now, the elements in the sample space of the event Z. Now, what is our event Z? Getting a consonant. Guys, do you know what's a consonant? In English language, there's vowels and consonants, correct? So vowels are all the A, E, I, O, U. Consonants are all that is not A, E, I, O, U. Do you know that? So what is our A, E, I, O, U? So A, E, I, O, U is E, I, O. So we have got 3 vowels here. Okay, out of our sample space, 3 are vowels. And so how many consonants do we have? Can you see what I'm doing here? I'm literally taking this 8 and grouping it up into, dividing up into vowels and consonants. And I can now tell you the elements in the sample space of our Z, which is N, V, R, M, and T. That's all the elements in our sample space, which you have 5 possible answers. If you understood this, can I have a thumbs up? Faham? So far, so good? Am I too fast? All right, good. So now let's go to one last question on this part, okay? Huh? Tak faham ke? Gloria, you don't understand, ah? Seriously? Which part you don't understand, girl? Oh, you mean faham. Okay, all right, okay. All right, now let's see, huh? Sample space, again, number of elements and the event Z. So our story here is choosing a multiple of 5 that is less than 50. Can I have all your answers in the chat? What is our sample space? A multiple of 5 that is less than 50. So what is the first multiple of 5? 10. Okay. Then it goes to 15. All these are multiples of 5, lah, correct? Then we'll go to 20. Then 25. You must list this down. You got no choice. Okay. 30, 35, 40, 45. Now, they said less than 50, right? So don't go and include 50. So it's 45, less than 50. Do you see that? Very good, Gloria. Very good. Well done. Now, how many elements do we have in that sample space? This is also easy already. No, 5 is not counted. 5 is the start itself. It's only 10 becomes a multiple. How is 5 a multiple of itself? Do you understand that? So 5 is not included in the game here. Okay. So we have 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 elements. Now we go to our special event Z, getting a multiple of 3. Which means you have got to look at your sample and look at which one number here is a multiple of 3. You know what's a multiple of 3, right? That means it starts with 6, 9, 12. So we have 15. Can you see that? Then 20, no. 25, no. You have 30, yes. 35, no. 40, no. 45, yes. Can you see now? 45, darlings, can divide by 30. Okay? And how do I even know that? Actually, there's a trick here. Any number where the digits add up, like 4 plus 9, 4 plus 5 is 9, right? 9 can divide by 3 words. So 45 can surely divide by 3. If I give you a number, 123, can it divide by 3? Yes. Take 1 plus 2 plus 3, you get 6. So 6 can surely divide by 3. So 123, you can, it's a multiple of 3. Now only you know me all these. Wait. Okay, learn. Okay. Any number, if you add up all the digits, and if it's can be divided by 3, then that particular number, no matter how big it is, can also be divided by 3. You just add the digits, okay, the value. All right, let's go to the this one. The sample space here is 15, 30, 45, and done. Okay, so clear this. Now, the next section we are going to go on is a bit more of more questions. But what's going to happen is I'm going to stop here and reboot and rejoin again. Okay? Can we do that?